So far, we've seen many different formulas for expanding or simplifying trig expressions, but sometimes we just need to express the product of a cosine and sine as a sum. And to do this, we use the product to sum formulas. The derivation of each of these formulas come from the sum and difference identities. Again, let's just write out the formulas, and then we'll see one example of how to derive one of these formulas. The first one we have is cosine alpha times cosine beta is equal to the following. The next formula we have is sine of alpha times cosine of beta is equal to the following. The next formula we have is sine of alpha times sine of beta is equal to the following. And the last formula we have is cosine of alpha times sine of beta is equal to the right-hand side. And let's go ahead and look at the derivation of this first equation. To do this, let's write out our cosine of alpha minus beta. This is equal to a cosine alpha cosine beta plus sine alpha sine beta. And also write out our cosine of alpha plus beta. This is equal to cosine of alpha cosine of beta minus our sine of alpha sine of beta. And what we want to do is we want to add these two equations together. So the left-hand side becomes a cosine of alpha minus beta plus a cosine of alpha plus beta. And the right-hand side becomes the following. Our sine of alpha, sine of betas cancel out, and we're just left with the following. So simplifying this becomes our cosine of alpha minus beta plus our cosine of alpha plus beta is going to be equal to 2 times our cosine of alpha cosine of beta. Now, dividing both sides by 2, we'll get our identity. So this becomes our cosine of alpha cosine of beta is equal to a 1 divided by 2 times our cosine of alpha minus beta plus cosine of alpha plus beta. And we're done. And in converse manner, sometimes we need to reverse the process that we just did. Sometimes we need to make sums into products, and we have another set of formulas that will allow us to do this. These are referred to as the sum to products formulas, and these are listed below. The first one we have is sine of alpha plus sine of beta is equal to the following. The next one is given by sine of alpha minus sine of beta, and this is going to be equal to the following. Then we'll have cosine of alpha minus cosine of beta is equal to the following identity. And finally, we have cosine of alpha plus cosine of beta is equivalent to the following. So now we'll go ahead and practice a few different problems using both sets of formulas. So the first problem we'll be looking at is we want to go ahead and evaluate cosine of 15 degrees minus cosine of 75 degrees. And we want to apply our sum to product formula. And recall that this is going to be given by cosine of alpha minus cosine of beta is equal to a negative 2 times our sine of alpha plus beta divided by 2 times sine of alpha minus beta divided by 2. This means that our cosine of 15 degrees minus cosine of 75 degrees is going to be a negative 2 times sine of 90 divided by 2 times sine of 15 minus 75 divided by 2. This is equal to a negative 2 times sine of 45 degrees times sine of negative 30 degrees. This is equal to a negative 2 times a square root of 2 divided by 2 multiplied by a negative 1 divided by 2. And this is equal to a square root of 2 divided by 2. Let's look at a problem where we're looking at a verification. And we want to verify that the cosecant squared minus 2 is equal to cosine 2 theta divided by sine squared theta. So let's go ahead and write the right-hand side out. We have our cosine of 2 theta divided by sine squared theta. And And we can go ahead and use our double angle formula up top, and this becomes a 1 minus 2 times our sine squared theta divided by sine squared theta. Now, writing this as separate fractions, this becomes a 1 divided by our sine squared theta minus 2 sine squared theta divided by sine squared theta. This is going to be equal to cosecant squared theta minus 2. And this completes our verification. Let's look at one more problem. And again, we want to verify the following identity, which is given by cosine of 4t minus cosine of 2t divided by sine of 4t plus sine of 4t. And this is going to be equal to a negative tan of t. Oops, I made a little bit of a mistake here. This should be a 2t. Now we'll go ahead and start with the more complicated side of the equation, which is the left-hand side. We have our cosine of 4t minus our cosine of 2t divided by sine of 4t plus sine of 2t. And we're going to apply our product to sum formula on the top and the product to sum formula on the bottom. And so this is going to be then equivalent to a negative 2 times a sine of 4t plus 2t divided by 2 times a sine of 4t minus 2t divided by 2 divided by 2 on the bottom times our sine of 4t plus 2t divided by 2 times cosine of 4t minus 2t divided by 2. So this is equal to, the 2's cancel, and we're just left with a negative up top. So we'll have a negative sine of 3t times sine of t divided by a sine of 3t times a cosine of t. So our sine of 3t's cancel out, and we're left with a negative tan t. And we're done with this verification.